So this is the assignment which we will try today. And as you can see, this is basically about embedded steel. You can see over there, different types of embedded steel. So there's type 1 shown over here, which is a steel plate. And you've got these bars at the back. They're shown over here in the top view, detailed as shown. This is phi 12 bars. And then there is type 2, which is similar. It's just that the bar is shaped differently and the location is given and the dimensions are given over there. There's type 3, which if we zoom in over here is basically very similar to type 2, but one of the bars has been flipped in the other direction. Then we have type 4 over here, in which once again we have a plate and we've got these rebars at the back. And we also have some shear keys. So the rebars would usually be used when you have tensile forces pulling out at the embedded steel, and the shear keys would be used when you have shear forces. And of course, the rebars can be used or they can be placed strategically in a way that even if you have bending moments, then those bars can take the tensile forces related to those moments. Once again, type 4 is like that. Type 5 is slightly different in that instead we've got shear keys, and instead of rebars being used for the pullout, we are using rag bolts. If you zoom in a bit, you can see maybe we have a section. Yeah, there we go. We have a section and we see that the rag bolts are used over there. Maybe a 3D view would be better. Yeah. So we have these rag bolts which have been used, and we've got the shear keys as well. And finally, there's type 6. So all the type so far, type 1, 2, 3, 4, 5, they have it's basically an embedded steel plate with these bars and shear keys at the back. Whereas type 6, on the other hand, is if you zoom in over here, it's a folded plate. It's not a normal plate. It's a folded plate with the bars coming out at the back, and they're kind of staggered. So if we have a 3D view of the same over here. So the bars are coming out of both sides of the folded plate, and they're staggered as well, so they're not clashing with each other. So the assignment is basically to model these different types of embedded steels. Now, before we start, some general information about embedded steel. Now, it is basically all the related commands are available under the embedded objects, which is itself under the formworks menu. So you come to the embedded objects and you'll see all these options over here. We've talked about anchor bolts elsewhere as well. But basically, the main tool which we'll be using to create embedded steel is this one over here called embedded steel connection. And if I were to press the shift key and open up the settings, you will see that there's a general tab, and then there are basically these 4 tabs called anchor bar placement, shear key placement, rag bolt placement, and anchor bolt placement. What that basically tells us is this is a tool which can create a plate for you, an embedded steel, and behind that plate, it can put 4 different types of things. You could have anchor bars. These are the ones we just saw in the assignment as well, of different diameters and different types and different shapes. You could place shear keys, which have a certain input, which you can use to create these shear keys behind the plate. You can have rag bolts of different types, and you can also have anchor bolts placed behind the plates. So this tool in general will allow us to create different sized embedded steel plates. Now, for each of these, not for all of them, other than the shear key, basically for the anchor bar, for the rag bolts, and for the anchor bolts, we have certain files which allow us to create our own company standards and company files. So for example, for anchor bar placements, we've got the U type, which basically looks like what you see on the screen. The RB type, which is this kind of a bar, you have control over these angles, so this could be a straight bar like that as well. And the L type, which is once again a special form of the same thing with some angles being zero. This being the perhaps one of the more commonly used ones. So, and this one, this anchor bar is basically controlled by a file. So just remember these names: the U type, the RB type, and the L type, and each one can have multiple. So, for example, when we choose the U type, you can have multiple U types which can come from the file. So let's just talk about that file for a second. So we're talking about anchor bars now. So if you go to, once again, this preferences menu and go to the company one, for example, you will see that towards the top, we had talked about anchor bolts file, but there's one called the anchor bars file. And if you double click on it, you will be able to see that if you remember, we had just seen these U types over here, and then the RB types, and then the L types. And so you can add your own. Once again, all the geometric properties are given over here. Even some information you can add over here regarding their capacities, their shear capacities and their axial capacities, for example. And you can then perhaps use those numbers to not only remind yourself of what this kind of an anchor bar, what kind of load it can take, but perhaps also use it for designing the embedded steel. So basically, this is the file which you can then, like I said, you can create your own new types, basically belonging to these three fundamental types, and then you can add them. And once you've added them, you can start using them. Now, similarly, there is behind the embedded steel, you can also have rag bolts. This is what a rag bolt will look like. And you can, just like we had the other file, let's go there again. Just like we had the anchor bars file, if we go down, you will find a rag bolt file as well. We double click on it. There are two types, the straight ones and the sloped ones. We'll perhaps talk a little about those as well. Once again, you can add your own rag bolts, and these rag bolts can then be used behind the embedded steels. You can have shear keys. Shear keys don't have a file associated with them, but you can use any profile as shear keys, or you can have anchor bolts going through. You can have holes in the embedded steel plate if you wanted to, for example. Now, this is the fundamental structure which we have over here. And the tool which we'll be using more often, like I said, will be this one, which will be basically calling these individual tools to actually create those embedded steels. So let's start with the first one, type 1 over here. It's a plate of thickness 10 millimeters, as you can see over here. And there are these anchor bars behind it. The anchor bars are 12 millimeter diameter bars. The length is sticking out is about 400 millimeters. The width which touches the plate is 200. And then we have these lips over here of 75 millimeters as well. So let's try and create this type 1 bar. We'll use these distances 250, 250, 50 from the edges. And then there's only one on the other direction. So when we go back to the model, what we can do is we can just zoom in over here, for example, click on this tool over here and select a point. So first of all, let me just press escape. And if you come over it, you'll see there's a long hint. There are multiple ways of using this. You can use it by selecting a single point and right clicking. You can use it by selecting 2 or 3 points, defining the exact work plane. Normally it will take it, if you only use a single point, it will use the current work plane as well. And you have some other options as well. You can actually create non-rectangular plates as well. But let's start off with a simple one. So let's just click it. Let's click on this point over here and let's right click over it, immediately right click. And when we right click, we see that let's press Alt D like that. See that this plate has been created. Now, the reason we are seeing it a bit odd is because of the rebar draw mode. And we can go over here and go to the rebar draw mode and say, basically toggle this like that so that we can see it better like that. So we see that the embedded steel has been created, and this is the macro symbol. We can click on the embedded steel, press M and enter, and the tool, the macro, will be opened. Now, if you go back over there, we see that the distances in one direction are 250, 250, 50 at the edges, and in the other direction there's only one, so there'll be a zero distance. And from the edge, the middle of this bar from the edge would be, so if this is 200, half of that is 100, and there's 100 from this point, so the middle would be 200 from the edges. So just remember these numbers: 250, 50, 50. Let's do that. Let's go back to the model like that. And over here we can say 250 space 250, and the edges were, let's remember, 50, 50, like that. And for the other direction, we can just give a edge distance of 200 and 0 in the other direction, like that. And when we say apply, immediately we get an embedded steel with those distances. Now, if I were to go back inside by pressing M twice, if I choose that rebar, for example, I can go in and change the, if I go in over here, I can change the plate thickness to 10 millimeters in my case. I can come back over here. Let's go back to the assignment. This distance coming out was given as 400, and this distance was given as 200. So going back in there, we can make this distance 400, and this distance was 200 to begin with, and this distance is given as 75, as far as I remember, like that. And the other one, this one is also given as 75, like that. So this one has an angle to it, but in our case, that angle is 0, like that. So this distance is 75, this distance is 400, and this distance is 200. If we just select those, we will see those numbers as well: 75, 75, 400, and 200 for each bar. And very quickly, we have managed to create this embedded steel. Now, like I said, we could have created it in any work plane which we wanted. We basically selected a point. We can also, by pressing M enter, we can also change the anchoring point. So it's right now it's anchored to the bottom left because I'd selected this point. I can anchor it to the middle if I want, like that. I can anchor it to any other point like that, and I can also give an offset to that anchoring point. So normally these embedded steels will be somewhere in a wall or in a column or in a beam, some concrete member, and you can actually locate them very easily. If you want to, you can even give them rotation angles around Z. So, for example, if you give it a rotation angle of 22 degrees, like that, it'll give the whole embedded steel a rotation, like that. You can also change, if you're working on a column or a wall, you can actually, despite the point which you've selected, you can actually give it an elevation by directly entering an elevation. So those things you can discover by actually using it. But the point over here is that we have only used the anchor bar placement. We haven't used the shear key, the rag bolts, etc. But for the anchor bars, there will be distances, and then there'll be edge distances, and then there'll be distances in the other direction and edge distances, and you can create your embedded steel accordingly. Now, if you've got multiple things in there, then whichever one causes the largest. So, for example, if you had rag bolts in there as well, or shear keys in there as well. Now, obviously, they'll have their own. So, for example, the rag bolts will have their own dimensioning from the edges, etc. And one of them will govern. So, for example, it might be that the rag bolts give a larger distance as compared to the anchor bars. So, in that case, the rag bolts will govern in that direction. And maybe in this direction, the anchor bars will govern. So that will depend on exactly what we want. But for the moment, we are focused on this type 1. And very quickly, by just entering a few points and a few numbers, we've managed to create the required embedded steel. Now, type 2 is basically very similar to type 1, the only difference being that the anchor bar behind it is not shaped like this, it's shaped like an L. So let's immediately go in and try and create that. Let's zoom out a bit. Let's select the same tool. Click on this point, right click, and we get our embedded steel. Select that, press M, enter. And instead of the U type, let's select the L type, like that. You can see immediately that the L-type bars have been created. And if you go back to the assignment, we see that the edge distance are 50, 2 into 100, and in the other direction, the edge distance is 75. So 50, 100, and 75. Let's go back in there. I keep forgetting 100 into 2. So we say 100 space 100. We can say 2 into 100 as well. And then 50 as the edge distance. And over here, the edge distance is 75. And the other distance is 0. Once we say OK, we see that that embedded steel has been created very quickly. Now let's check out type 3, which we notice immediately is basically the same as type 2. The only difference being that in this one, it was a straight angle coming out like that. Whereas in this one, there is a different type. It's coming out like that, and with a 45-degree angle like that. So what we can do is, if you go back to the model, let's just create a generic one to begin with. Point, right click, and then we can select this macro button, for example, and say match elements to this one, the one we just made. So we've got that, but this is not the one we want. So we double click on that, and instead of the L type, we choose the RB type, I guess. We say it like that, or maybe it's different. Let's see what the requirement was. The requirement was that it should come out like that with a 90-degree turn and then a 45-degree turn. So what we need to do over here is we can double click on that. And over here, instead of a 45-degree angle, we can give it a 90-degree angle like that, or minus 45, I guess, would be the right number, or 0 perhaps would be the right number, something like that. And then we have this 45-degree last piece coming out. But in our requirement, 2 of those pieces are coming out in this direction, whereas the third piece, the middle piece, is going in the opposite direction. So what we can do in such cases, because from the macro, we are not able to do that. It'll basically apply the same. But if you remember, all these things created on the back of the embedded steel are basically also given as tools separately. So each of these, for example, let's say if I double click on the middle one, only that one, that itself has its own parameters, which I can then modify over here. So if I've got this 45 over here, if I just put a minus in front of it, like that, I can get exactly that kind of a orientation. Because all these pieces, whether they're rag bolts or anchor bars or whatever, when they're created at the back, you will also have individual control over them at the end of once you execute this one. This macro will be able to create them according to certain parameters. But if you want to slightly modify, or you could even, if you want to move them, for example, you could, let's say, after creation, if you wanted to move one a bit, although you can enter those distances from inside as well, let's say you wanted to stagger them in the X and Y directions a bit differently from those options, you could always do that as well. So here I have created the type 4 with the 4 anchor bars and the 3 shear keys. If you go back to the assignment, this is type 4. Actually, I haven't corrected this 350 distance. I'll need to correct that. But basically, there are 4 anchor bars with the distances of 500 between them and 75 at the edges, and then 600 in the other direction and 150. So if we go back inside, if we press M, enter, like that, and go to the anchor bar, you will see that the distance of 500 between them and 600 between them, and then 150 edge distances, and then 75 and 75 is the other one. And let's correct while we're at it. This distance needs to be 350 and 250. So we go back in and we can correct this one to be 350, and that one is 200 as well, and this one is 50 as well, so that should be fine like that. So that's the corrected position now. And as far as the shear keys are concerned, they are 3 shear keys like that, spaced 150 millimeters apart, and the edge distances would turn out to, because this total distance is 900 and this distance is 300, so the edge distances would turn out to be 300 from here and 300 from here, and in the other direction it will be half of 650, which will be 325. So that's basically what I've done. If you go to the shear key placement, you need to turn them on from here because by default they're turned off. Once you've done that, you can give a 2 into 150 distance, 300 edge distances, and then 325 edge distances for the other direction, and then 0 because there's only one line. So once you do that, you get your particular configuration. Of course, as always, once you're okay with the particular configuration, you can always save it away as a macro preset, because in a lot of projects you have certain embedded steels which keep repeating again and again throughout the project. So you can give them certain names and save them away as presets as well. Now I'll skip type 5 because it's more of the same, just that you can use rag bolts and you can use the distances. But I'll focus on this type 6 over here, because instead of a normal rectangular plate, we have a folded plate like that, and we've got the bars coming out from this side as well as from this side. And the lengths of the folded plate are 250 by 250. So let's start by working on those. Let's go back to the model. Like that. Let's create a folded plate over here, 250 by 250. What we can do is we can go to our steel command, go to our folded plate, say hover over this point and say dx minus 250, like that, and click on this point, and then hover over the same point and say dy 250, like that. Enter and then right click to basically get the folded plate. Let's go back in. The height of the folded plate was given as 400. This is the height. So we will use the same height over here as well. Let's go back in. We can give this number to be 400, like that. And now we can focus on creating those anchor bars at the back. Now, if you notice, the 3D view is perhaps better to explain. So they're coming out from both sides like that in both directions, and they're staggered, so they're not clashing with each other. And if you look at the vertical distances, they're 50, 50, 50 all the way down. So 1, 2, 3, several layers of 50 each. And the distance in the other direction between them is also, if we zoom in like that, it's also 50. So because it's a 10 millimeter thickness plate, we'll have 95, 95 left on each side. So for the first one, we can say 95 down and then another 50 down to get to the points. So let's go and create some points over there. Let's look at it from the top like that. Maybe we can let's see, let's go back to the, so we need a clean 250 like that and clean 250 like that. So let's change that a bit. Let's double click on this one and change it to that. Yeah. So we have the numbers now, and now we can create basically the point 95 down from here. So what we can do is we can hover over this point and say dy minus 95 to get the first point, and then hover over this point and say dy minus 50 to get the other point, like that. And we can actually create those bars. How do we create those bars? We'll be directly using the anchor bar command over here, because since we are not using this one, which creates, because that one only works when you have a plate, not a folded plate. But if you have a folded plate, then you will need to directly use the anchor bar commands directly at these points. Now, the way this tool is used independently is that you give an origin, an x direction, and a y direction in such a way that the bar will be created in the negative z direction. So if we select this is the origin, this is the x, and this is the y, then the z will go in that direction. Let's see, this is the z will be in that direction, but we want it to come out in this direction. That's the minus z, which is what we want. So what we'll do is we'll click on this one, select the origin point, select this any point along this direction to give the x1, and then we want something going down for the y. So we'll hover over this one and say, for example, dz anything minus 20, 25, whatever. When the moment we do that, we'll immediately get a bar going in the negative z direction, an anchor bar. You can double click on that, change the type to L type, like that, and we see that actually this is exactly what we want. Let's go back to the thing. The height which we want is 160, and the projection which we want is 50. So let's see what we have. We have 160 and 50. Those are the defaults, but we can of course, if we wanted to, we could double click on this and change those numbers as well. Now, if you remember, this first layer was at a distance of 50 from the top, and then the second one 100 further, because this one is the staggered one. So 50 from the top, then 100 more, and then 100 more. And then 100 more. That would be the first set. Let's do that. Let's go back to the model. First, let's move this so that it's 50. So we can just select it and say move linear, and select this point, and they say that it goes to dz minus 50 from there. Just hover over that, so it's dz minus 50, like that. And then whatever z offset we get from the vector, we change the other one to 0, like that. And then we can just copy it down, I guess, 1, 2, 3 copies at a distance of 100 each, like that. Say copy linear, this time in the minus 100, and 3 copies, like that. So we have those 3, and then we can just copy them all to this side, this distance. Let's just copy those as well, linear, like that, 1 copy. And the only difference being that for these ones, we will need to change this angle from, I guess, where the rotation angle is. It comes down, it turns at an angle of 90. We'll need to make that minus 90. Let's try this to be, let's see what minus 90 does. Yeah, that's what we want. So what we can do is we can do the same for the other ones as well, like that. And now that we have these bars coming out of the folded plate from that side, we can do the same. I mean, I don't have to repeat it, but what you can do is we want them staggered. So we once again create these 2 points, 95, 50, but this time we'll move them in the middle of this line, and instead of 4 copies, we'll have 3 copies, and we will be able to create those rebars as well. So here is the final result. I've basically done what I just described. I've created the anchor bars from the other direction, color coded them as well. You can see there's no clash. They're in the middle of, they're going through each other basically, but not clashing. So you can, whenever you want to create an embedded steel, which is outside the scope of this command over here, you can always build it up from scratch using any plate of your choice, individually using the anchor bolt, the rag bolt, the anchor bar, and the shear key commands, and you can basically create any type of embedded steel which you would like.